Welcome to the Ideal video series on frequently asked questions. This is a series of short videos to explain how to approach common scenarios, model specialized BMPs, or troubleshoot typical issues. Today's video is about the basics of Ideal and how to get a model built and run on your computer after you've got it installed. Ideal is a post-construction water quality model for designing stormwater best management practices. It is a design tool created to assist engineers and watershed modelers with sizing and evaluating their performance of BMPs. Ideal uses a simple drag-and-drop interface to create treatment trains of unlimited size and complexity. The model is process-based, meaning that algorithms use physical, chemical, and biological dynamics to calculate the actual treatment efficiency of each BMP. Instead of assigning a percent pollutant removal to an entire class of BMPs, Ideal calculates the pollutant removal for each unique situation modeled. When you open Ideal, this is what it will look like. The model workspace covers the majority of the screen, and the object library is on the left side. To begin, we recommend first double-clicking the storm inputs icon here that looks like a storm cloud. This is where you will select the location of your project and your simulated storm or annual probability distribution of storms. If you don't take care of this first, you'll be prompted to enter the location when you try to edit your first object. In this version of Ideal specific to Greenville County, I'll choose South Carolina as my state and southern Greenville County for a specific rain gauge. If you're running a single storm, you'll have to check the defaults and fill in the season and antecedent moisture condition. If you select the annual probability distribution of storms, the values are automatically filled out. Next, choose whether you want to run a priming storm by clicking on the Priming Storm tab. You only need to run a priming storm if you have a wet pond in your model. It will not cause inaccuracies in other models, but it will cause a longer runtime. If you have a wet pond, we recommend a 2 to 4 inch storm. Look for another video later explaining priming storms in more detail. Once you have your location and storm selected, you may begin building your model. On the left side of your screen, you'll see different objects categorized by the blue headings. Let's look through each category. The watershed objects are used to define the area of your site that is receiving rainfall and conveying the runoff to a BMP. These will always be at the top of your model. You may have an entirely pervious area, entirely impervious area, a combined area, or several different subwatersheds going to different BMPs. To select a subwatershed, click on the icon and drag it over to the workspace. To edit the object, either double-click or right-click and select Edit. In each of the subwatershed objects, you will need to click on each tab and define the inputs for your specific site. Best management practices are next. These may be added to your workspace the same way we selected the watershed object. Once you drag it over, open the object to edit it by double-clicking or right-clicking and selecting Edit. Each BMP has tabs that are unique to the inputs needed for Ideal to determine pollutant removal. We will not go through each BMP in this video, but specific BMP input videos may be created in the future. Leave a comment on this video or email us to let us know which ones you'd like to see. Logical objects include a junction, diversion, and outlet. A junction can be used to combine the runoff from two different upstream objects. A diversion can be used to divert flow from either a watershed or BMP into separate flow paths. This can be used to simulate a diversion structure that bypasses flows after a certain volume or one that splits flows by percentage. The outlet is used to tell the model where to end the simulations. Every model will need to have an outlet, and this will be the last object in the treatment train. These objects are edited in the same way as the other objects. Conveyances are used to connect objects. Every object will need to be connected in order for your model to run successfully. Options are circular conduit or a pipe, open channel, non-routed connector, and a diffuse connector. The non-routed connector translates the flow from upstream to downstream without any time lag or attenuation and is the most commonly used conveyance. This one should almost always be used to discharge from BMPs because the BMP objects themselves contain inputs for barrels that account for timing. The diffuse connector simulates a level spreader, and the user inputs the width over which flow is spread. Again, these can be edited in the same way as the other objects, though not all of these objects require inputs. Storm sewer objects are available at the bottom of the object list and include some SWIM model inputs for simulating inlet capture and hydraulic grade lines. These were added originally to make importing from a SWIM model possible. Because these have no effect on water quality, we recommend they not be used in a typical water quality model. As you can see at the bottom, this pane displays errors and warnings. Errors are caused by inputs that are missing, contradictory, or not allowed, and the model will not begin a run until they are fixed. Warnings are displayed to warn the user of an unusual circumstance, like a riser height that's higher than an emergency spillway, but the model will still run. Saved models can be opened through Ideal by going to File, Open, and navigating to your file. You can also open files by double-clicking on them in Windows Explorer or on the desktop. You may need to save your model file, a .iar file, on your hard drive while working on it, as you may not be able to access your company's server to open and edit the model. The model is run quicker from the hard drive as well. Here's an example of a completed model with all inputs finished. Before running a model, we suggest you validate it by clicking Run and selecting Validate. This will confirm that there are not any errors or warnings. All errors and warnings will be listed in the bottom panel. The model can run with warnings, but you will be alerted to confirm that your inputs were intentional. The model will not be able to run if there are any errors. Once all errors are corrected, you may select the Run tab and click Run. If you run a single storm, the model will run fairly quickly, depending on how large of the model and treatment train that you're running. If you are running an annual probability distribution of storms, it may take longer, as the model will be simulating 72 individual storms throughout your treatment train. A dialog box will show you how many storms are left and an approximate runtime remaining in the simulation. Once the model is run, a box will pop up saying the run was successful and you can select OK. Then a second box will pop up asking if you'd like to see your output report, and you can select OK there too. Under the Reports tab, you may change the report type from HTML to PDF, and if you make changes to your model, you will have to rerun the model for the report to update. Thank you for using Ideal. As always, if you have questions about Ideal, please contact the StormOps support team at info@stormopssoftware.com. Also, visit our website and follow us on LinkedIn to get the latest news on support and new releases.